video is be able to convert decimal numbers, like for instance, base 10, which is, a decimal. I want to convert it to any base. Let's assume base 2, which is binary. So let me show you the first method here. I'm going to take 173 in base 10. What is this in binary? So I divide by 2. When I divide this by 2, that gives me 86, remainder 1. So I'm going to take this 1 here, and I'm going to put it right there. That's 1. Okay? Then I take 86 divided by 2, and this is 43. Remainder 0. So that's where my 0 goes. So I'm going right to left. 43 divided by 2, it's actually 21, remainder 1. So my 1 goes right there. Then you take 21 divided by 2, which is actually 10, remainder 1. Then if you take 10 divided by 2, it's actually 5, remainder 0. And then if you take 5 divided by 2, it's actually 2, remainder 1. And then you take 2 divided by 2, it's actually 1, remainder 0. And then I'm going to take 1 divided by 2, which is 0, remainder 1. So now my number 173 in binary, it's actually 1, 0, 1, 1, 0, 1, 0, 1, 0, 1, 1, 0, 1, 0, 1. So this is in base 2, and it's actually 173 in base 10. So now, how do I prove this? Well, I can go back here. Well, another method would be actually, look at this. Take 173 divided by 2. That's 86. I'm doing integer division, so no decimals. 86, which is 43. 43 divided by 2 is 21. 21 divided by 2, let me start this better. So I'm repeating myself. 173 divided by 2 is 86. 86 divided by 2 is 43. 43 divided by 2 is 21. 21 divided by 2 is 10. 10 divided by 2 is 5. 5 divided by 2 is 2, and then 1. So this is my second method. Now all I have to do is, wherever there's an odd number, I'm going to put a 1. That's a 1. That's a 1, 1, 1. The rest is zeros. See that? So therefore, these two, so there are two ways to solve this problem. I can do, like a brute force here, just keep dividing by 2, ended up with this number, or I can just simply take the number and keep dividing it by 2 until I get to 1. And then if you see an odd number, you put a 1, odd, 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 and these two numbers are the same. So this is now in base 2. So if I look back at this number here, this is 2 to the 0, 2 to the first, 2 to the second, 2 to the third, 2 to the fourth, 2 to the fifth, 2 to the sixth, 2 to the seventh. So let me see this. So all I care about the ones, the digits, these numbers with the 1. 2 to the 0 is 1, so I have 1 unit of 1. 2 to the first is 2, 0 units, so that's with my 0. 2 to the second is 4, I got 4 there, 1 unit. 2 to the third is 8, I have 1 unit. 2 to the fourth is 16, I have 0 units. 2 to the fifth is 32, I have 1 unit. 2 to the sixth is 64, I have 0 unit. 2 to the 7 is 128. So let me see when I add this. 128 plus 32, this is 130, 60, this is 130 plus 30, so that's 160, 168, 172, 173. So it does work. So this is my number. So now I did this method here to prove that how you can divide. Go back to the number now. So if I look back here, I'm going to leave this number as it is. So this is my my result. So if I have base 10 into base 2 or binary to decimal, so 173, it's actually 10101101. So I put my 2 there, put my 10 there. So that's this number, and this is how we can prove it. Another way, I'm going to erase this problem here. So watch how we can do this. So I have this number here, 10101101. Now, how do you go back and convert from binary back to decimal? So this is binary. The best way is I'm going to bring this number down. See? I'm going to bring this number down. Now remember, this is base 2. Now 2 times 1 is 2. 2 times 1 is 2. 2 plus 0 is 2. 2 times 2 is 4. 4 plus 1 is 5. 2 times 5 is 10. 10 plus 0 is actually 10. 2 times 10 is 20. 20 plus 1 is 21. 2 times 21 is 42. Plus 1, that's a 43. 2 times 43 is 86. Plus 0 is 86. 2 times 86 is 172. Plus 1 is 173. See that? So this process, this algorithm here is known as Horner's algorithm. This is Horner's, how you convert base 2 back to base 10. So you simply go into the multiplication. While the other method that, besides Horner's, which I showed you earlier, so Horner says keep doing the other method. We go through the brute force method as I had it done. So you raise to the power of 2. So 2 to the 4, 2 to the 5th, 2 to the 6th, 2 to the 7th, and then you calculate. This is the one I showed you earlier. And Horner's method is an efficient way, and you can do it for any numbers, any binary number system. So all I'm doing is, if this was a 0, I'm going to bring down the 0. So I can show you another example of Horner's. So for instance, if you have a number like this, so I have a 0, 1, 1, 0, 1, 1, 0, 1. So what is this number in decimal? Now, I'll show you both ways. And so this number is 2 to the 0, 2 to the 1st, 2 to the 2nd, 3rd, 2 to the 4th, 2 to the 5th, 2 to the 6th, 2 to the 7th. Now, all of these are unsigned numbers. These I'm not using, positive, negative number. 2 to the 0 is 1. So 2 to the 1st is 0. 2 to the 2nd is 4. I have 1 unit of 4. 2 to the 3rd is 8. I have 1 unit of 8. 2 to the 4th is 16. 0 unit of 16. 2 to the 5th, 32 units of 1. 64 units of 1. And then 0 units of 127. So when I end up adding this number, I get 96. So this is 96. That's 100. This is 108. So this gives me 109. So this is the first method, which you raise to the power. Now I can go back Horness. So if I apply Horness algorithm to this, bring the 0 down, okay? Now remember, this number is in base 2, so keep your 2 there. Okay, 2 times 0 is 0. 1 plus 1, 1 plus 0 is 1. 2 times 1 is 2. 2 plus 1 is 3. 2 times 3 is 6. 6 plus 0 is 6. 2 times 6 is 12. Plus 1 is 13. 2 times 13 is 26. Plus 1 is 27. 2 times 27, this is 54. Plus 0 is 54. 54 times 2, so this would be 108 plus 1 is 109. See? So this binary number in decimal is 109. So that's the same process. So we can go either way. Again, just a shortcut here. So if I do 109 in binary, in decimal to convert to binary, so remember, this is 54. 54 by 2, which is 27 by 2, which is 13 by 2, which is 6 by 2, which is 3, and then 1. So again, so if we look at the odd numbers, so 3 by 2 is 1, and that becomes, so this number is 1, 1, 0, 1, 1, 0, 1. See? And so that's equivalent to that. So all I did was I showed you how to convert from base 10 to base 2. I mean, this can be done for any base. Thank you.